Assalamu alaikum, viewers. One of my students has sent me a question to solve. So that looks like a very good question. So I thought I should share that question with you people, that how to solve that question. Okay, this is a past paper question. I have got a WhatsApp from one of my students that he needs help in this question. So I thought, why should I make video with that? Okay, this is question number five, and I don't know which paper is this one, so I'll let you know later. There's a pulley on one side. This is two particles of masses zero point 0.8 kg and zero point 0.2 kg are connected by a light inextensible string that passes over a fixed smooth pulley. The pulley is smooth, so it will not affect the motion. The system is released from rest. That means the initial velocity was zero with both particles a zero point 0.5 meter above the horizontal floor. See diagram in the subsequent motion. The zero point 0.2 kg particle does not reach the pulley. That means it will not hit here. This will not hit here with the pulley, and it will not stop the motion till it reaches to ground, right? So that the magnitude of the acceleration in the particles is 6 meter per second. So that's very nice that you are given the answer for the acceleration, and uh, it's in your benefit that you are given the answer and you can reach to the answer very easily. Okay, and find the tension in the string. Okay, obviously when the system is released, this is the heavier object and this is the lighter object. So motion will be in this direction and in this direction. So if we draw this one, this will move upwards and this body will move downwards, right? Okay. The cable in the tension will pull it upwards, and the weight which is equal to mg, that is zero point 0.2 into 10 is equal to 2 Newton, will work in the opposite direction. While in this case, this one, as it is moving downwards, so weight is directing to this side. This is 8 kg, and the tension is working to this side. Okay. If you take this system only, this 8 kg is working in the direction of motion. And what is the force, called, which is working in the direction of motion? That is called the driving force. And the tension in the cable is working in the opposite direction of the motion. So that is called the resistance force. So this is the resistance force and this is the driving force. As you know that driving force minus resistance force is equal to force net always, which is equals to MA. In the first system, that would be 8, sorry, this is 8 Newton. I'm really sorry for that. This 8 minus T is equal to zero point 0.8 A. So you got the first simultaneous equation. And for the second system, this one here, this is working, as the direction of motion is upwards, and this T tension is working in the direction of motion. So this is driving, and this weight is working in the opposite direction of the motion. So this is the resistance force. So for the second system, driving force minus resistance force equals MA, and driving force is obviously the tension in the cable, and resistance is the weight, which is 2 Newton, is equal to MA. M is zero point 0.2 in this case, and this is your second equation. Okay, so from the first and second equation, if you solve these two simultaneously, this one and this one, if you solve these simultaneously from equation 1, T is equal to 8 minus zero point 0.8a. So put in the second equation. So that would be 8 minus zero point 0.8a minus 2 is equal to zero point 0.2a. So if you bring this zero point 0.8 to the other side, that will become 6 is equal to zero point 0.2a plus zero point 0.8a, and a is equal to 6 meter per second square. So you got the acceleration of the motion, in this case, that is 6 meter per second, and you were given the as you were given the answer, so it becomes more easy for you to compare your answer, and you can say that yes, I've got the correct answer. So shown, you write down as you were supposed to show your answers, so you have shown the answer. The next, you have to find out the tension in the cable. So to find out the tension in the cable, what we can use any one of these simultaneous equations like 8 minus t equals zero point 0.8a, or we can take the second equation. Second equation is better because t will become more easy to make it make t as the subject of the formula. So 0.2a, substitute the value of a, that will become zero point 0.2 into 6 plus 2. So this will become 6 times 2 is 12, 1.2. This is 3.2 newtons. So you got the tension in the cable, 3.2 newtons. I'm sure you have got it. There is no problem in the question. Okay. Uh, what is the next part? Okay, next part we have to find out. Let me copy it down. Okay, okay. So when when the zero point 0.8 kg particle reaches the floor, it comes to rest. Obviously, when the object will hit the ground here after zero point 0.5 meter, traveling up zero point 0.8 meter, it will hit the ground, and they are saying that it will be zero point 0.8 reaches the floor, it comes to rest. Okay, find the greatest height of the zero point 0.2 kg, zero point 0.2 kg, the other one. So we'll find out how much distance zero point 0.8 kg and zero point 0.2 kg. Obviously, you can see that these two. Okay, let me copy down this one. So मैं इसको so that I can use it over there as well. Okay, diagram. I need the diagram on diagrams. So I have to come back again and again for the diagram. So I have copied down here. Okay, so when this will hit the ground, so they'll travel zero point 0.5 and it will go zero point 0.5 above, right? Okay, when it will hit the ground, its final velocity will become zero. And this, sorry, its final velocity, it will hit with some velocity, and its u was 0 meter per second, right? So for 0.8 kg weight, 0.8 kg weight, the u initial velocity was 0 meter per second, and we have to find out, and distance is 0.5 meters. So v square, we know that a is equal to 6 meter per second square. So acceleration was 6 meter per second square, and the distance it has to cover to reach the ground is this one, 0.5 meter. So we'll find out at what velocity, with which will, what velocity it will hit the ground. Okay, v square is equal to u square, v square minus u square is equal to 2as. So v square minus 0 square is equal to 2 into 6 into 0.5. So this will become v square is equal to 6. V is equal to square root of 6 meter per second. So you got the velocity at this time. Okay, now as they are connected by the same string and the tension in the cable is equal everywhere, so when this zero point 0.2 started projecting upwards, its initial velocity was 0 meter per second, and when it covered 0.5 meter, when it has gone up 0.5 meter, as it comes down 0.5 meter, u is equal to 0 meter per second, and it hits the ground with v is equal to 6 meter per second. It stopped because it cannot go down the floor or ground. So, but when this will reach here with 6 meter per second, now there is no driving force more upwards. There is no driving force upwards because when this will hit the ground, it will stop, driving this. There will be no tension in the cable anymore, right? So with this velocity, with this initial velocity, 6 meter per second, it will travel upwards and starts decelerating, and its final velocity will become zero. So it would be like this. Its journey will be like this. Okay, let me make you the diagram. So this will be the journey. It's 6 meter per second. So its initial velocity will be now 6 meter per second, and final velocity will become 0 meter per second. So we have to find out how much distance it will cover with this in this situation when it is decelerating. So what would be the deceleration as it is going freely upwards? So there would be the gravitational force, which will be, the deceleration. So v square minus u square is equal to 2gs. So what is v square is 0 minus u square is 6. Sorry, this is square root of 6. I'm really sorry. Square root of 6. Square root of 6 whole square is equal to 2 into minus 10 because it's going upwards, and the distance we have to find out. So this will become minus 6 is equal to minus 20 s. So s is equal to minus 6 over minus 20 meters. So s will be zero point 0.3 meter. So it has traveled zero point 0.3 meter with the thrust it was having when this is stopped here. It has a thrust uh, velocity square root of 6 meter per second, and it will gradually decelerate, and it will stop. Its final velocity will become zero, or is during this situation it will travel this zero point 0.3 meters. Okay, how much distance? They are saying find the greatest height, zero point 0.2 kg particle above the floor. Now, this is the floor. It was already zero point 0.5 above, zero point 0.5 more with due to this movement, and then plus this is zero point 0.3. So we'll add up all these. This is the height of the zero point 0.2 kg, maximum height, the greatest height of zero point 0.2 kg above the floor, right? So greatest height of zero point 0.2 kg particle above the floor is equal to zero point 0.5 plus zero point 0.5 plus zero point 0.3. So this will become 1.3 meters. So I'm sure that Moise, you have got it, and this will be beneficial for the rest of the people as well, the rest of the students as well, who have not asked this. But it was a good question, so I thought I should share this question with all of you. Thank you very much for watching. Allah Hafiz.